Um, so I know. So the last sort of transformation, and then that we're really going to look at is what happens when you multiply the x values before you put into the function. So far we've added and subtracted values from x and y, and we saw that those were shifts. And we actually multiplied the y values, and we saw that multiplying the y values stretched it out vertically or compressed it vertically. And then we've also looked at reflections and odd and even functions. And this is the last major transformation is when you multiply the input values by a value. And I think we actually looked at this a little bit, just hinted at it on Thursday. And that's when if you take a look at this function that we started with, x cubed plus 2x squared minus 4x minus 1, and you look at what happens when you multiply the x values, and then you look at the graph, this is y2, right? And it looks like all the y values are the same height, so the maximum's the same as that, this minimum's the same as that, but we sort of scrunch them together. Would that be an appropriate way of saying it? And then maybe if we actually went back and did something like, let's see, 0.5x. Nope, that's not what that says. I wonder, .x. I don't know if it would know what to do. 0.5x. So there's the original function, and here comes, check that out. What did it do there? Pulled it, stretched it, right? So I feel like we have a good intuition that this would be like a horizontal stretch or compression. Is that all right? Okay, can we summarize? Can we put everything together? Let's do it. Okay, so in general, if you have a function that's equal to a f of b times x minus c plus d, we have a, b, c, and d. They're all doing something to that function. Pick a letter and tell me what it's doing. Let's put this into one big mega lesson. Evan, what do you want to pick?
D.
What does D do? What does it do?
Starting value.
All right, so it's like the initial condition. What does it do in general? So it definitely does something to the initial y value. It shifts the initial y value to d units. It does something to the rest of the y values as well, which is on par with exactly what you said. You're picking a very specific thing that d does, and it does. It gives us the initial y value. Rafi? Yeah, it moves the whole function up. It's a vertical shift, and let's actually say, let's say up if d is greater than 0, and down if d is less than 0. Is that okay? Yeah. Okay, good. Thanks, Evan and Rafi, on that one. Rafi, calling someone to pick another letter, preferably someone that wants to.
C.
All right, C. What's C going to do? All right, C is a horizontal shift. And I did something very interesting there. I put x minus c in the parentheses. So we should probably talk about whether it's left or right, given that I put x minus c in there. Sam?
It's going to shift right because, should I say
Sure. Or tell me right if what?
if C is negative, if C is less than 0, then the horizontal shift will be right.
I don't think so. Because I put the negative sign here, So x minus c. So if you have x minus 3, if c is positive, right, x minus a positive number,
So
and that's going to shift it.
C. But if C is positive.
It's going to be right if c is greater than 0. In this case, right? In this case, if c is some sort of positive value and I subtract it from x, subtracting it's going to shift it that way to the right.
I thought it was the opposite. I thought you said it was the opposite.
No, but look at what I did.
I was assuming you were shortening.
Would you prefer me to do this? I can do that if you
I
want.
was just assuming that that's what was going on.
Those say the same things, right? So if I remember, it doesn't say, minus doesn't mean that c is negative. X minus c, I'm actually going to turn it back because I want to. If c is greater than 0, this looks like x minus 5. 5 is greater than 0, right? The minus sign stays. What if, well, not what if, we know it's going to be left if c is less than 0. Because if c is less than 0, give me a value that's less than 0. All right, negative 5. So x minus negative 5 turns into x plus 5. Okay, and that's going to be a shift. If I have x plus 5, that's going to be to the left. It's going to be the opposite, right? So make sure that you're reading this correctly. And you could switch it to this being plus and then switching the left and right, but I don't want to do that. I think that's, I don't think we should need to do that. You can if you want. I don't think we should need to do that. So this does say it's opposite of what you would think. And the reason why is we're shifting the inputs, not the outputs. Evan?
So I could say if x plus c is greater than 0, then you shift left.
You could say x plus c. If c is greater than 0, then you shift left.
I thought if it's the sum value of x plus c.
It's what c does to that value. It's not x is a variable here. So it's not like when x gets bigger, we start shifting it a different way. Whenever you have an input that's x plus or minus c, that will shift the whole function horizontally. And that shift depends on what c is, not on what x is. X is a variable. X is always going to be changing. C is a constant. It won't be. And, if this feels funny to you, think about it like 5 times f of negative 2 times x plus 3 plus 8, right? That value, right? Well, actually, I should have written it like this. Minus. No, x is a variable. X takes all, x, for all intents and purposes, if the function is well defined, x is going to be all real numbers. X is always going to be changing. X is the independent variable.
That's the principle that I was using earlier. I was basically saying that x plus negative c.
All right, well, so here, right, do you agree that this x minus negative 3 is going to be a shift to the left?
Yes.
Yeah. And why is it a shift to the left? Because c is actually less than 0, okay? Because we're keeping this minus sign there. All right. I think we'll think about it, and we'll come back and maybe continue to ask questions about it. Let's see if we can finish up A and B. What do you have, Peter?
A is like the function compressor stretcher.
All right. In which direction?
Compressor.
No, but what,
like
this or this?
This.
Try again. Perfect. Awesome. So A is affecting the function, the y values. So A is going to be a vertical stretch or compression. All right. So Peter sets us up with the stretch or compression, and then we should probably talk about when is it going to be a stretch and when it's going to be a compression. Morning. Mo, you want to take a shot at it? I think it's from Thursday. I'm not saying you have to, but if you want to, I think we can probably go back to Thursday. Jennifer? Oh, yep. All right, good. Let's hear it, Mo. All right, so if A is greater than 1, we have a stretch. Keep going. Awesome. Okay. And that's what we might think, right? If we multiply something by 5, we think it would get bigger. The y values would get bigger. You know what we didn't talk about, or maybe we did? What happens if A is negative? Okay. If A is less than 0, it also provides for a reflection across X. So in addition to compressing it or stretching it, if it's negative, not only will it compress it or stretch it, but it will also flip it across the x-axis. All right, and then last but not least, we talked about it today, and I think we can use process of elimination to figure out what B is going to do. Jennifer, you want to talk to us about B? Is that a no? Not really. Not today. Some other day. Tom? It definitely is. All right, and let's see. If B is greater than 1, what does it do if B is greater than 1? Remember we looked at, this is when it's 0.5, and when it was 2, when it was bigger than 1. All right, so if it's 0.5, that's what it looks like if we go and do, something like, put a 2 in here. And we graph it. Here's the original function, and here's y of 2x. So greater than 1, stretch or compression? Isn't it squeezing all those x values together? We would call that a compression. And if B is between 0 and 1, it's a stretch. And again, that's a little counterintuitive. It seems backward, but it's because we're doing something to the input. So anything that happens inside the parentheses is going to be sort of opposite. Yeah, that's a good way of saying it, Tom. I like that. You know what else we didn't look at? We didn't look at what happens if B is negative. Let's do that. Let's see if instead of multiplying by 2x, if we multiply by negative 2x. So it's going to be a compression and, I don't know. Whoa, check that out. Let's see. Hold on, I gotta check that out. What are you giggling about, Travis? Stop. Hold on, so let me just see if it's negative. We would do -1. Is that what we do? Do we get a flip over the y-axis?
Wow, nice picks. And you?
Yeah, Tom, you're right. So multiplying by negative will also flip it across the y-axis. All right, so let's see. I ran out of room. All right, so
Who's the person that decided to do A before B? I blame that person.
it's my fault. If b is less than 0, whoops, not then reflection across the x-axis. Whoops, no, you did not say x-axis, Tom. You correctly said y-axis. I don't know why I'm writing that. Good. All right, kids, there it is. That's like everything sort of in a nutshell. There are 4 things that, I guess there are 4 things that you're primarily responsible for knowing how a function gets shifted, compressed, or stretched. And this would be a summary. So whatever the function is that you're given, you can create new functions that are related by changing the parameters, A, B, C, and D. And those parameters are things that affect what the shape of the graph looks like. It doesn't change the type of graph it is. Like if it's a parabola, it's going to stay a parabola. If it's a line, it's going to stay a line. But it changes the properties of that function. Evan.
You know how you said, oh, for C, we'll skip A, get that question later.
Yeah.
I have a question.
Okay.
I don't know why I'm exhausted. So you know how you're like, oh, well, if C is negative, then you're minusing by a negative, so
Yes.
therefore it's positive,
So wait,
therefore it goes to the left.
Yes. That was a perfect statement, Evan.
Okay. So, but I feel like when you do that, you're minusing by a negative number. I don't feel like that's the same as saying like by adding by a positive. Like I feel like minus a negative number doesn't change the fact that the number is negative. It's just like minusing by a negative number, you still have a negative number, but with the way that we just went over it, it made it seem like minusing by a negative number actually literally changes the number to a positive number. Like I see like functionally how it does, but I feel like
X minus negative 3 is the same as X plus 3.
exactly, but I feel like you can't say that 3 is equal to negative 3.
It's not. It's definitely not. And I would never say that 3 is the same as negative 3.
So then
I'm saying if you choose to make this a minus sign, then X minus negative 3 would be equivalent to saying X plus 3. But in this case, C is 3, and in this case, C is equal to negative 3. So you have to look, what are you choosing? I'm choosing the minus sign. If I chose this to be a plus sign, right, if that was a plus, then that would be the same as adding 3.
You say the jurisdiction of the variable C engulfs the mathematical sign before it?
Okay, I've done a bad job.
Mr. Bavarian.
Hold on. Okay, so here we have this function, and we can do one of 2 things. We can either do x plus 3. Okay. And in that case, it's a plus. All right, so that would be the same as if I went back and changed not a minus sign, but I made that a plus sign. I'm choosing not to call that a plus sign. If you want to call it a plus sign, that's fine, but then these left and right, they're going to switch. Okay, so I'm calling this a minus sign. I was doing it because I thought it would make things easier. It hasn't. So if I graph this, the x plus 3, we should be fairly confident it's going to shift it to the left. Right? Hold on. That's exactly the same as if I decided to do a minus sign and do -3. Now, in the first instance, I was using a plus sign and said C was positive. And we said if you're going to use a plus sign and say C was positive, then you'd have to switch these. This time, I'm going to do the same thing except use a minus sign and say C is negative. But you can't because it depends on what C is. Like if you add a negative value of C, it's not like.
Yeah, no, we know that.
If I say,
It's actually minus.
I know, but if I say right now that whenever, so you have to decide, is it going to be X minus or X plus? Do you want me to call it X plus? I'll do it. Okay, so if it's X plus, then if C is less than 0, it shifts it to the left. Sorry, if C is greater than 0. If it's X plus a number where C is positive, it shifts it to the left. If it's X plus a number where C is negative, it shifts it to the right. Do people like that better? I know you've been waiting. Go ahead.
Can I show you real quick like what I think we're thinking?
Sure. That would probably help, right?
You're thinking too much.
Maybe.
No, I wrote it down. So X minus C is equal to X plus negative C. Therefore, C is negative.
No, it's not.
No?
No, because if C, negative means opposite. C can be -2, so negative C would be +2. Negative just means opposite. C doesn't have to be positive or negative.
All right.
Like, negative means opposite. So if I tell you that C is greater than 0, the opposite of greater than 0 is less than 0. But it doesn't mean just because I say negative C that it's the negative value. -2 is a positive value.
Yeah. So I think you should define exactly.
Good. We agree then.
You should define C as C plus like the math.
I'll leave it as this. I think you guys like this better, and I'll leave it like that.
I'm saying like, but if we ever go on a test where it's minus, the situation is minus.
Then
I think it'd be good to know that like C includes the sign before. Like if you have C equal.
So if you ever see X minus 3, you need to know that means X plus -3, right? Is that what you're saying? You need to take this sign into account.
Yeah, like basically like C equals that sign and that number. C doesn't just equal that number.
Okay. There's no way.
Can we not have a true-false question on that?
I'm definitely going to have a true-false question on that now. All right. Hey, that was a lot of me talking about the same thing and not doing a great job, but I think maybe Rafi has it. I think maybe we're overthinking a nuance. Good. So we did horizontal. We did vertical stretches on like 2-3 nights ago, whatever, Thursday night. Did they go good, bad, or ugly? Were there some questions that were sort of giving you difficulty that you wanted to talk about, or did you feel good about the vertical shifts? I think there were some tables, I think there were some graphs, and I think there were some equations. I think there are lots of ways of asking those questions. 32 is something that you did not like, or could have gone better or something. Gosh, the poor students who are going to try to listen to this. All right.